Okay, let's continue. Number 15, in order to determine if treatment X is successful in improving eyesight, a research study was conducted from a large population of people with poor eyesight. So specifically people with poor eyesight, 300 participants were selected at random. Half of the participants are randomly assigned to receive treatment X, and the other half did not receive treatment X. The resulting data showed that participants who received treatment X had significantly improved eyesight as compared to those who did not. Based on the design and results of the study, which of the following is an appropriate conclusion? So you have to kind of try to find like flaws in what they're going to say right now, because they're going to ask you guys questions about like this, where they ask you, okay, which one makes sense? All of them might make sense, but one of them makes sense more than the other ones, or the other ones are just kind of flawed or biased. So let's see. Is it true that treatment X is likely to improve the eyesight of people who have poor eyesight? According to what I read so far, that makes sense. Treatment X improves eyesight better than all other available treatments. Since there was no discussion about other treatments, I don't like that answer. So I'm just going to put a little X next to it, because if I had to pick between A and B, I'm definitely steering towards A. Treatment X, letter C, treatment X will improve the eyesight of anyone who takes it. I don't like, again, I feel a little sketchy about that one because it's only given to people with poor eyesight. So I don't like that one. Between A and C, I like still A. And D, treatment X will cause a substantial improvement in eyesight. Well, again, between A and D, this was only given to people with poor eyesight. So I don't know that to be true. So that's where, again, all of them could be true. Which one's the most true? Or which one's the one you feel the most comfortable with? Okay. All right, number 16. Graphs of functions f and g are shown in the xy plane. Which of the following functions does f plus g equal 0? So in order for f and g to equal 0, that means when I add up the two y values, because that's what f of x is, it's with the y value, they're equal to 0, okay? So I'm going to look at these and I'm going to say, okay, if I pick a random point, for example, let's say this point right here and this point right here, what's the y value? The y value here is 2 and the y value here is -2. If I add those up, do I get 0? Yes. That perfect. Okay. For which of the following values of x? Oh, but what's the x value there? Because that's the real question. So 1, 2. Okay, so -2. X equals -2. So that works. Okay, so I like that one already. But let's see what I could have done. I could have also taken these and plugged them in. So what's f of -3 plus g of -3? F of -3. So if I go to -3 and I go here, both those y values are -1. Does -1 plus -1 equal 0? No. So that's why -3 doesn't work. Exact same thing's going to happen if I plug in -1. Well, what's going to happen if I plug in 0? If I plug in 0, one point is over here, and the other point is all the way down here. Let's call that 2, and let's call that 1, 2, 3, 4, 5, 6, 7, 8, 9. So -9. If I add those up, do I get 0? No. When I said f plus g is equal to 0, that must mean there have to be opposites because they would cancel each other out. And the only time that happens is when b is equal to -2. Okay? All right, let's take a look at number 17. The quantity of a product supplied and the quantity of this product demanded in the economic market are functions of the price and product. The functions above are the estimated supply and demand functions for a certain product. The function S of P gives the quantity of the product supplied to the market when the price is P dollars, and the function D of P, I should say, not D times P, but D of P, gives the quantity of the product demanded by the market when the price is P dollars. So how will the quantity, so we're specifically talking about the quantity here, of the product supplied to the market change if the price of the product is increased by $10? So if I look at this one, because again, S deals with the supply or the quantity, what's going to happen if the price of the product increases by $10? What I'm going to do is I'm going to plug in two numbers. I'm going to plug in P equals 0 and see what S of 0 is equal to. And if I plug that into this equation, 1/2 times 0 plus 40 is equal to 40. So what's going to happen if the price goes up to 10? So I'm literally going to plug in 10 like this and see what happens. And if I plug that in, I can use my calculator. But if I plug in 1/2 times 10, that's 5, plus 4, 40, it's 45. So all of a sudden, I can use an example of numbers to figure out which one makes the most amount of sense. Now, if the price goes up by 10, look at that. The quantity will go up by 5. So the quantity supplied will increase by 5 units. Okay? Number 18, at what price will the quantity of the product supplied to the market equal the quantity of product demanded by the market? Okay, so in that case, those two have to be equal. So that's what I'm going to do. I'm going to set those equal to each other because it literally says they're equal to each other. So if I do this and I try to solve for P, what do I get? Let's see, add P over. So that gives me, or actually, yeah, let's add P over. So you're going to get 1.5P plus 40 equals 220. Subtract 40, 1.5P equals 180. And then I can divide by 1.5, divide by 1.5. And if I divide by 1.5, my calculator is going to help me with this one. It's 180 divided by 1.5. You get 120. So that must be the correct answer. Okay. Number 19, graphene, which is used to manufacture integrated circuits, is so thin that a sheet weighing 1 ounce can cover up to 7 football fields. If a football field has an area of approximately 1 1/3 acres, how many acres can 48 ounces of graphene cover? This is all about unit conversion, and the best thing you guys can do for unit conversion is to use your dimensional analysis. So we know that 1 football field is, 1 ounce of graphene is equal to 7 football fields. Okay, we know that 1 football field is equal to 1 1/3. Let's convert that. That's going to be 4/3 acres. And we're asking how many acres would 48 ounces equal? So I'm going to start off with 48 ounces. 48 ounces. I have to convert ounces to football fields. I know it sounds kind of crazy, but that's what we're going to do. So ounces goes on the bottom, football fields go on top. So 7 football fields equals 1 ounce. Ounces cancel. Now I got to go to acres. Well, I know that 1 football field is equal to 4/3 acres. And what I can use is my calculator to multiply all that stuff on top. So let's see, what's 48 times 7 times, now 4/3, make sure you guys put that in parentheses, and you'll get about 448. And that looks like about 450. Number 20. Michael swam 2,000 yards on each of 18 days. The scatter plot above shows his swim time for and corresponding heart rate after each swim. The line of best fit for the data is also shown. For the swim that took 34 minutes, so we're going to specifically isolate the graph to this 34-minute marker. Okay, there's only one in there. There's one that's just a little bit above 34, but there's exactly one at 34. How many beats per minute less was predicted by the line of best fit? So if I'm looking at this, line of best fit goes to 150. This dot goes to here. Okay, now a lot of people would just say 1 because they see 1 box part, but look at that carefully. There are 5 tick marks in between 130 and 140. So that means each tick mark is actually going to be 2. So the answer is 2 on that one. 21. Of the following 4 types of savings account plans, which option would yield exponential growth? Now, exponential, the difference between exponential is this is exponential, and then this is linear. Okay, linear has a constant slope. So that's one thing that you have to remember is look for things that don't have a steady slope, things that are increasing kind of on a strange pattern or really increasing on itself. So the more I have, the more I grow. A, each year, 2% of the initial savings is added to the value of the account. So let's actually come up with a savings account. We're going to put $100 into this account. Each year, 2% of the initial savings is added. That's a constant growth of $2. That's linear, that's not exponential. Each successive year, 1.5% of the initial savings, so $1.50, plus 100, so plus 100, is added to the value of the account. Again, that's pretty steady. Although that's a lot of money, that's pretty steady because it's just always increasing by $101.50. That's still linear. C, each successive year, 1% of the current value is added to the value of the account. So that is the answer, but if you're not sure, I'll come back to that one. D, each successive year, $100 is added to the account. So that, again, that's steady. I don't want steady for exponential growth. Steady is good for linear, not exponential. So that's why D is not it. Going back to C, each successive year, 1% of the current value is added. So if I start at $100 and I add 1%, now I'm at $101. But now I'm going to add 1% of this. What's different from this and, for example, A, it says initial here, and here it says current. So this is always changing because 1% of $101 is $1.01. So I'm actually gaining a little bit more than just that $1, and that means I'm starting to make bigger strides. Okay, number 22, the sum of three numbers is 855. One of the numbers x is 50% more than the sum of the other two numbers. What is the value of x? So the sum of three numbers, x plus y plus z equals 855. One of the numbers, x, is 50% more. Now, careful there, don't put 0.50. If you put 0.5, that's half, right? I want 1.5 because it's 1 plus the rate gives me more, or 1 minus the rate gives me percent less. Is what 50% more than the sum of the other two numbers? So that would be y plus z. So what I can do here is actually I can find the value of x, but what I don't want to do is I don't want to substitute in x because that makes x go away. Instead, I'm going to divide by 1.5, divide by 1.5. So I know y plus z is equal to x over 1.5. And I'm going to plug this in for this y plus z. Notice I can substitute in expressions, not just individual variables, because y plus z, y plus z. So I know x plus x over 1.5 equals 855. I am not a fan of fractions, so I'm going to multiply everything by 1.5. I get 1.5x plus x equals, and then what is 855 times 1.5? That's 1282.5. Okay, on the left side, what's 1.5 plus 1x? That's 2.5x equals 1282.5. And finally, divide that by 2.5, and I get 513. So I'm looking for an answer of 513. There we go. Okay. Number 23. The angles below, or angles shown above, are acute. Sine of angle A equals cosine of angle B. If A equals that and B equals that, what is the value of K? So a couple ways you could do this. There is one way suggested overall, and that is to remember a property of sine and cosine. Now, what is that property? Well, if I give you sine of 30, that's equal to cosine of 60. And if I give you sine of 45, it's equal to cosine of 45. And that property happens to be that these angles are always complementary. They always are going to add up to 90, no matter what. So if that's the case, that means A plus B is equal to 90. And I can plug in A, which is 4K minus 22. And I can plug in B, which is 6K minus 13 equals 90. I'm going to get 10K minus 35 equals 90. So what does K equal? Well, I would add the 35. So 90 plus 35 is equal to 125 divided by 10. So 12.5. Another thing you can do here, especially if you get stuck on this problem, one of the answers is here, right? I would take an answer like say 12.5 or 5.5, or you would start somewhere, and I would plug them into the values of K, and I would then come up with a number for A and B and plug that into the calculator, because the calculator has the sine button and cosine button, and I would figure out what's sine of A and what's cosine of B, and then figure out are they equal or not. Only one of these is going to work, and that happens to be 12.5. Okay. Next, we have number 24. So number 24. Mr. Cole has a beaker containing n millimeters of solution to distribute to the students in his chemistry class. If he gives each student 3 millimeters of solution, he will have 5 millimeters left over. In order to give each student 4 millimeters of solution, he will need an additional 21 millimeters. How many students are in the class? So what I'm going to do is basically I have two variables, the number of millimeters in the beaker and the number of students. Let's call that X for number of students. Okay. And anytime you have two variables, you need two equations. So it says, if he gives each student 3 millimeters of solution, so that means 3 times the number of students, he will have 5 millimeters left over, so plus 5 is equal to the number of millimeters in the beaker. In order to give each student 4 millimeters, okay, he will need an additional 21. So therefore, if he takes the number of millimeters and multiplies it by, or 4 times X, it won't be enough. So what has to happen is he has to take n and add 21. Perfect. Two variables, two equations. Let's substitute in this for this. So we have 4x equals 3x plus 5 plus 21. So then I have 4x equals 3x plus 26. Subtract 3x. I get x is equal to 26, so there have to be 26 students in the class. Okay. All right. Number 25, a grain silo is built from 2 right circular cones and a right circular cylinder with an internal measurement represented by the figure. Of the following, which is the closest volume of the grain silo in cubic feet? So if you flip it back, and again, I tell you guys to always bookmark that formula page. If you flip back, you can find the formulas. The formula for the volume of a cylinder is equal to pi r squared times height, and the volume of a cone is the same thing, but multiplied by 1/3. Okay, so of the following, which is the closest volume, so let's plug everything in. So the cylinder right here is going to be pi times the radius, which is 5 squared times 10. So that's going to be about 250 pi for just the cylinder. Now, the cone, what about that one? So that's going to be 1/3 for the cone times pi times the radius, which is 5 squared, but the height is only 5. So that right there is going to come out to be, if I keep it as a nice clean answer, it's going to be 125 over 3 pi. I could type that in and I'll get a decimal for that one. But what I want to do is I just want to stress that there's 2 of these cones, one on top, one on bottom. So what I have to do is I have to double it. So the cylinder is 250 pi, and then the 2 cones is really 250 pi over 3. I'm just doubling this number. And I'm going to let the calculator do the work from here. And that would be 250 times 3.14, which is about 785, plus 261.66. If I add those together, I get about 1,046.6, which is close enough to 1,047.2. So it was a rounding error somewhere because I used 3.14 instead of the pi button. But at the end of the day, it's still going to be close enough. Okay.